Hello and welcome to the next lesson on transformations, and the kind of transformations we're doing this time are stretches. So let's get cracking on our stretches. So in terms of stretching, what are we talking about? Let's see. So no, we're not talking about stretching for a long run. In geometry, a stretch is similar to an enlargement or a reduction, only it's done in something only, in one direction. So it's done in one direction only. There we go. So here's an example of one. So just like how enlargements are defined by our scale factor and our center of enlargement. So just like how enlargements are defined by a scale factor and a center of enlargement, which you learned in the last lesson, stretches are defined by their stretch factor and a thing called the invariant line. Let's see. The invariant line is a line where no point along it will move in the stretch. So the invariant line in the diagrams above, so looking at this one, the invariant lines in these ones would be a vertical line. This would be the invariant line. So just imagine, they're done separately on two separate axes. So the invariant line basically means it's this particular diagram, it's only stretching out sideways. It wasn't stretching upwards or downwards at all. So the invariant line therefore is a vertical line. It means at no point along this invariant line here will any points move, but they will stretch out sideways instead. So the invariant line is a line where no point. The one above would be in a vertical. Okay, a vertical line, which is basically the vertical line is the y-axis. This is because the object only stretched sideways. It didn't stretch upwards or downwards. So basically the invariant line is a line where the stretch is done relative to. It didn't stretch upwards or downwards, it stretched out from that yellow invariant line. So let's keep going on. So what we're asked to do here, example, find the stretch factor, K, and invariant line for each of the following stretches. So let's see, what was the object? The object, I'll just draw in red, the object was ABC. So here's our lovely little object. And the image is what's left behind. If you want, you can draw that in purple too. Don't have to. Just reminding you that that's how I tend to do it. I might just only draw the object in middle. So this one is the image, just reminding you, and the red one is the object. So let's see, what I tend to do is I tend to look at a point like A going to A dash. So generally you can see it's not stretching out sideways at all, it's only stretching upwards. So that means our invariant line has to be a horizontal line. And in this case, it turns out, like if you see it going from A to A dash, it doubles from the x-axis, and going from C, you go up 4 units, and up to C dash you go up 8 units. So that means the invariant line is consistently the x-axis. Here's our invariant line. So the invariant line, and it turns out, if you look at both of these, the invariant line is actually just the x-axis for both of these, because they're not stretching out sideways at all, they're only stretching upwards. And when you look at the object, oops, sorry, the object in this case is a dotted line, ABC, here's our object. They're all stretching relative to that x-axis. So I'm just going to write for both of them, the invariant line for both is the x-axis. Quite often it's the x-axis or the y-axis, or it could be just another kind of horizontal line. For example, y equals 5, y equals negative 4, or another vertical line. So that's just easy because for both of them, it's the x-axis. But what's our scale factor? Our scale factor for the first one is, let's see, going from A to A dash, it doubled. And going from C to C dash, the distance from the invariant line doubled. C is 4 units away, C dash is 8 units away. Going from B to D dash, the distance from the invariant line doubled. So we can say K equals 2 as for example, A dash is twice as far from the invariant line as A. And for this one over to the right, let's see, going from A to A dash, it halved. Going from B to B dash, it halved. Going from C to C dash, the distance from the invariant line halved. So we can say K equals 1/2. For example, as C dash is half as far from the invariant line as C. So we just had to state what the scale factor is, but we're just writing notes for ourselves so that we can look back on this in year 11 and remember how we did it. Now there's some more examples down here, same thing. Just state what the invariant line is and what's the scale factor. So the ones above had horizontal invariant lines because they stretched vertically. Whereas these ones, let's see what the object is. Let's mark in the object, A, B, C. Similarly, let's mark in the object on the other one, A, B, C. You can see that they're stretching sideways instead. So when they're stretching sideways instead, the object is, the invariant line is vertical. It's stretching up sideways away from the invariant line. Now let's have a look at a few points. Let's see, going from A to A dash it doubled, going from C to C dash it doubled from the y-axis. Just check, I always check first of all, is it the y-axis that's the invariant line? So let's see, going from B to B dash, from the x-axis it doubled because it went from B is 5 units away and B dash is 10 units away. So invariant line we've confirmed is the y-axis. I'm just going to show you that happens to be the same in the next one. So if you look at the next one, going from the y-axis, A to A dash, it halved. Going from B to B dash, it halved because it went from 5 units to 2.5 units. And going from C to C dash, it halved. So we kind of need to check all three to double check that the invariant line is the y-axis. So let's just write that once. The invariant line for both is the y-axis. It's not another kind of vertical line, like it's not x equals 2 or x equals -1. Now they've both got different scale factors, stretch factors. So stretch factor, sometimes they call it scale factor, stretch factor, same thing. We just call it K. So let's see, what is the scale factor for the first one? Let's see, going from the red object to the black image, or we can show the purple if you prefer, it kind of stretched away, it got further away. So it's kind of doubled, would you say? Going from A to A dash, the distance from the yellow line doubled. Going from C to C dash, the distance from the yellow line doubled. And going from B to B dash, it went from 5 units away from the invariant line to 10 units away. So K equals 2. Let's give it a reason why, as for example, B dash is twice as far from the invariant line as B. All relative to the invariant line, which happens to be the y-axis. Similarly, let's do the next one. Going from A to A dash it halved, going from B to B dash it halved because it went from 5 to 2.5, going from C to C dash it halved. K equals half, let's give an example of y, is A dash is half as far from the invariant line. As A was. Brilliant. Let's keep moving on. Try to get through this nice and quickly. So here's another example. Examples, of course. Consider the triangle ABC, points A, B, and C, under a stretch with invariant x-axis and scale factor of 2. So I'm going to draw in my invariant line first. Invariant x-axis. So I'm going to draw in my x-axis. Just to remind myself, that's my invariant line. Helps to draw in the invariant line. And now I'm just going to, and the scale factor is 2, but we've got to draw the original image first. So we're going to draw, the original object, draw object. Now, so A is -1, 2, -1, 2. B is -1, -3, and C is 4, 2. So let's do that one. C, A, please use a ruler. B, please use a ruler. So now I'm going to do the image in purple. So consider the triangle. So we're saying us to consider the triangle and the stretch. Well, it didn't actually tell us what to do, so I'm just going to draw it. Maybe it's going to ask you to state the coordinates. If it asks you to state the coordinates, fine, draw it and then state the coordinates. Didn't ask me what to do here, so I'm just going to draw it because I think I should have had an extra instruction to just draw it. So scale factor of 2. So let's see, from the invariant line, let's do A dash first. A is here, so from the invariant line, A dash has to be twice as far. It's not stretching sideways at all. It's just stretching vertically because our invariant line is the x-axis. C, going to C dash, because the scale factor is 2, so it has to be twice as far. C dash, going from the yellow invariant line to B, that went down 3 units, so B dash we have to go down 6 units, which in this case is going to take us to here, 6 units from the invariant line. And then we'll just connect those lovely lines up. Please, please, please use a ruler. I don't have much time, so I'm just, oh dear, trying very bad image. Nice. Okay, let's keep going. So same picture, same original triangle, -1, 1, blah, blah, blah. But this time, invariant y-axis and scale factor k equals 1/2. So I'm going to draw my invariant y-axis first. Invariant y-axis. I like to draw that because it really helps keep me on track. Maybe use a highlighter or something if you like. When I draw it by hand, I can use a little highlighter. Let's draw our original object. Let's draw object first. So A was here, C was there, and B was here. A, B, C. So we're just drawing the same object as the first question had. And now let's draw the image. So scale factor of 1/2. So scale factor of 1/2, so whatever A is, A dash has to be half as far from the invariant line. I made a mistake. I forgot that my invariant line is the y-axis. So A is 1 unit from the y-axis, so A dash has to be half a unit from the y-axis. B is 1 unit from the y-axis, so B dash has to be half as far from the y-axis. The invariant line is 4 units from C, so C dash has to be half as far, it has to be 2 units from the invariant line, has to be half as far. And then we just connect all the ways up. So let's connect. Consider connecting that one. This one goes down to here, and then we connect down to here. Oops, please use all that. And that's our image. So just if they wanted you to state the coordinates, then you would have to then state the coordinates as well. But I didn't kind of put that instruction, so I'm just going to now, image equations, very similar, easy enough. Just draw the original line, object line first, and then deal with the stretch. So I like to put in the invariant line first, because I forget otherwise. Invariant line, y equals 1. So invariant line, y equals 1 is through here. Here's my invariant line, y equals 1. Now let's draw the object. Y-intercept is -1, and the gradient is 2. So go up 2 across 1, up 2 across 1, up 2 across 1, and so on. Down 2 across 1, down 2 across 1, and draw a nice line through it. I really don't have much time, so please, please use a ruler in your ones. So that's our y equals 2x minus 1, which would label the thingamajiggies. And scale factor is k equals 1.5. So let's see, from an invariant line, if a point is on the invariant line, it doesn't change in the image. So we've got a point right here as well on the image. That it's 1.5, so 1.5 times as far. So going from the invariant line up to the next point, that went up 2 units. So 1.5 times 2 means go up 3 units instead. And then the next one, as you can see, is 4 units from the invariant line. So instead, 4 times 1.5, go up 6 units instead. And you can see the y-intercept was 2 units from the invariant line. So 1.5 times 2 means go down 3 units from the invariant line instead. This next point down was 4 units from the invariant line. 4 times 1.5 is 6. So count down 6 units from the invariant line, not from the x-axis, but from the invariant line. There you have it. And draw a line through your lovely points. This is much better than mine. Now we need to state what the equation is. Like what is y equals mx plus c. This one's easy enough because you can see y-intercept from the graph. Y-intercept is at -2. And the gradient, you can see you're going up 3 across 1. Rise over run. You can use two coordinates and work it out with the gradient formula instead. We can see it's a positive gradient going up 3 across 1. So our equation is y equals 3x minus 2. Our image equation, let's label it. Y equals 3x minus 2. I'm labeling it in purple. That's my image equation. Now let's really quickly do this because I'm moving on. Invariant line x equals -2. So let's draw that in. X equals -2 will be a vertical line cut through x equals -2. X equals -2. We've got the same object. The same object is still just y equals 2x minus 1. Same one as before. Minus 1, go up 2 plus 1, 2 plus 1, 3 plus 1, down 2, back 1, down 2, back 1, down 2, back 1. Draw a line through it all. It's our object line, y equals 2x minus 1. Now this is interesting because we've got a vertical line this time. Scale factor equals a half. So let's see. This first point, the y-intercept, is 2 units away from the invariant line. So on the image it should be half as far because our scale factor is a half. The next point up was 3 units from the line, so it should be 1.5. Sorry, but halfway across. The next one was 4 units from the invariant line, so halfway across is here. The next one was 5 units from the invariant line, so halfway across is here. Next one was 6 units from the invariant line, so halfway across is there. And going down as well, this one was 1 unit from the invariant line, so halfway across. The next one cuts the invariant line, so it should stay where it is. Next one was 1 unit, so half across. Let's rule those up with a ruler, not freehand like what I'm doing here, which is dodgy. Got to do our y equals mx plus c. So you can see from the graph that I've drawn, it's easy enough to just look at this one. So the y-intercept is at 3 this time. And the gradient, it's easy enough to see as well. Don't have to use a gradient equation, it's just rise over run. We go up 4 and across 1, which equals 4. So our image equation, y equals 4x plus 3. Okay, easy enough. And last page I'll do super quickly, so I've got to go to class now with you guys. So example, describe fully the single transformation. We'll see a few questions in the topic assignment like this maybe. We'll see, describe fully the single transformation which has occurred when object ADD is mapped onto image DEF. So here's the object, I'll just draw it in red. Here's the image in purple. So a single transformation, we want to know for a stretch, what is the invariant line and what is the scale factor? That's what we need to just know. And we need to know it's a stretch, of course. Okay, so let's see. If you notice, each point on the image is 3 times as far away from the x-axis as each point on the object. So our invariant line is the x-axis. And you'll notice, as I'm just pointing what I mean by that, point A is 1 unit away. Point D, which is its corresponding point on the image, is 3 units away. Point D, which on the object, is 3 units away. Point F, its corresponding point, is 9 units away. B, you can think of this one, if that helps, call that one B dash instead. Call this one C dash. Call this one C. And it's also A dash. With that. So we can say it's a stretch. We've got to say it's a stretch, translation, whatever it is. Stretch with the invariant line being the x-axis. So I'm going to say the invariant x-axis. And my scale factor is 3, because each point on the image is 3 times as far from the invariant line as the thingamajiggy. So what we're saying is that the red image maps onto the purple or the pink, the red object, is the object, maps onto the purple image. You might have guessed already, it's an invariant x-axis again, so nothing too exciting there. Let's see, so if this is A here, this would be A dash here. And what's the connection? Oops, no, sorry, put it the wrong way around, as you've noticed, because the image is the purple. So this point here is A dash, and this one here is A. So going from A to A dash, the distance went from 6 to 3 from the invariant line. So it's a stretch again. Again, pretty boring invariant x-axis, no y-axis this time to make life exciting. Sorry about that. And scale factor, if you get what K is, I'm going to write it down. Scale factor K is 1/2. Okay, so thank you very much, and that's the end of this lesson on transformations and stretches. Thank you.